Alright guys, here we go again. This is chapter 4.2, number 13, 21, 61, and 62. We're doing implicit differentiation. Implicit differentiation, algebra is so important. You guys are going to mess up if you don't follow your algebra. You got to know your derivative rules and everything, but remember the one rule of implicit differentiation. Anytime you take a derivative of y, then write dy dx. You're telling us that you took a derivative of y with respect to x. So we'll start off with our x squared y minus x y squared equals 4. This is problem number 13. The question just says find where the slope is defined. We're going to start off with our x squared y. We're going to have to do the product rule. So x squared times the derivative of y, which is 1, but anytime we take the derivative of y, we got to write dy dx, plus derivative of x squared, which is 2x times y, minus, and then I'm going to put parentheses around this so that I can make sure I keep my algebra correct. We're going to do the derivative of x, which is 1 times y squared, plus 2y times x dy dx equals. Then the derivative of 4 is 0. Alright, now we want to group the dy dx's and we want to distribute this negative sign through. So I'm going to get x squared dy dx, this minus 2xy dy dx. That's this right here. Notice how I switched it to xy. I always try to do it alphabetical, and that's just, it's not, you don't have to. I just do it to make it the same in my problems always. Plus 2xy minus y squared equals 0. We move this over to the other side and factor out the dy dx. We get x squared minus 2xy dy dx equals y squared, that's that y squared added to the other side, minus 2xy, and then divide by this, dy dx equals, we're just dividing everything by that, we got y squared minus 2xy divided by x squared minus 2xy. Alright, so remember the derivative does not exist when the denominator equals 0. So I would just take that denominator, x squared minus 2xy, make it equal to 0. Go through, let's say x squared equals 2xy, divide by x equals 2y. So the derivative does not exist anywhere x does not equal 2y. So we got to plug that back into our original equation to figure out where this exists. Where does x equal 2y? So it's pretty easy. We just take the x is equal to 2y. We plug it into there. And we got 2y squared times y minus 2y times y squared equals 4. So we got 4y to the 5th minus 2y cubed equals 4. Looking at this one, I would say probably need to use our calculator to go ahead and punch that into the calculator and find the zeros to figure out where these y's are. And that will lead us to that other. Sorry guys. 4.2, number 13. X equals 0, what's going to happen on this one? Or y equals x over 2. Yeah, I guess this is, I apologize about that. That's the only thing they want you to know is that right there. Kind of a weird question, but definitely something that will come up on the AP test. Find the lines that are tangent and normal to 6x squared plus 3xy plus 2y squared plus 17y minus 16. Find the lines. Oh, and number 21 also gives us a point at negative 1, 0. I didn't write that down. Great. Alright, so we just take a derivative. We got 12x plus 3 times x dy dx. We're taking the derivative of that y, which is 1, dy dx, plus y times the derivative of x is 1, plus 4y dy dx. Everybody forgets that dy dx because they're so excited they remembered the product rule, and they forget to do it there. And then this one also plus 17 dy dx equals 0, because the derivative of 6 is 0, the derivative of 0 is 0. We're going to group all these. We got to distribute that 3 through to everything. So we got 3x dy dx plus 4y dy dx, plus 17 dy dx, plus 12x, plus 3y equals 0. So move these over to the other side and factor out the dy dx. 3x plus 4y plus 17 times dy dx equals negative 12x minus 3y. Divide by 3x plus 4y over 17. 3x plus 4y plus 17. And that gives us our dy dx. So now we want to find our dy dx, and we got to remember this little notation that we have. I'll move to another piece of paper. Okay. So remember it says to find it at negative 1, 0, right there, negative 1, 0. So we're going to do dy dx at negative 1, 0. That means our x value is negative 1, our y value is 0. So we just plug it into the derivative. Negative 12 times negative 1 minus 3 times 0 divided by 3 times negative 1 plus 4 times 0 plus 17 equals, that's 12. This is negative 3 plus 17 is 14. So our slope is going to be 6/7. Okay, remember, anytime we want to write a tangent line, we know y minus y1 equals m times x minus x1. We've got our slope, we've got our point, which is at negative 1, 0. So we got y minus 0 equals 6/7 times x minus 1, minus a negative 1. There's our tangent line, B. Our normal line is y minus 0 equals negative 7/6 times t plus 1. Done. Okay, don't make these harder than they really are. And the last one, we got to do a second derivative. So this is also another multiple choice question. Make sure you guys aren't forgetting to do the actual multiple choice. So the first question just says dy dx. So we got 2x minus x dy dx plus y, because we're just doing xy. So we got the derivative of x, which is 1, times y, which is y, plus 2y, don't forget that dy dx, equals 0. Okay, distribute everything through, so we get 2x minus x dy dx minus y plus 2y dy dx equals 0. In one step, I'm going to factor out the dy dx's and move these over to the other side. This becomes y minus 2x. That's just adding it and subtracting that. Factor out a dy dx, and that gets me 2y minus x dy dx. And divide by 2y minus x, and we get this. So our answer is y minus 2x over 2y minus x. We look at our multiple choice. This is problem number 61. Our answer, y minus 2x over 2y minus x, is A. So the answer is A on our paper. Okay. Now we go to take the second derivative, which means we're going to have to do quotient rule, because we want to take the derivative of this. So we got our high is y minus 2x. Our low is 2y minus x. Okay, now we take this and take the derivative of that. D high is going to be the derivative of y is 1 dy dx minus 2. The derivative of the low is 2 dy dx minus 1. Alright, so now we go low, 2y minus x, d high, dy dx minus 2, minus high, y minus 2x, d low, 2 dy dx minus 1, all divided by low squared, 2y minus x squared. Okay, so I'm just looking at the answers right there. We've got all right, so now we're going to go ahead and we're going to plug this dy dx back into here. So we got 2y minus x times y minus 2x over 2y minus x minus 2 minus y minus 2x times 2 y minus 2x over 2y minus x minus 1, all divided by 2y minus x squared. Alright, so that's, you never ever want to leave dy dx in your answer. So you got to replace dy dx. We know dy dx is this original equation right here. So now it comes down to a bunch of algebra. So the trick to this is we have fractions inside of fractions. We want to get rid of those fractions. So we're just going to multiply everything by 2y minus x, this thing by 2y minus x, this thing by 2y minus x, and this thing by 2y minus x. So we're going to get 2y minus x cubed on the bottom. What I'm doing is I'm doing 2y minus x to here, here, and 2y minus x to there. Okay, so then on the top, I'm left with 2y minus x times 2y minus x times that gives us y minus 2x minus, okay, this is 2 times 2y minus x, 4y plus 2x. My goodness, this is ugly. This one gives us y minus 2x, or 2y minus x times this. Okay, we're going to be left with this y minus 2x times 2 times y minus 2x, because the denominator goes away. And then we're going to do minus 2y plus x. Totally ugly. I get it. It's totally ugly. Lots and lots of algebra going on here. We got 2y minus x times, let's see, can we combine anything? That 2x and that 2x cancels out, and we get y minus 4y, which is negative 3y. Okay? This is 2y minus 4x minus 2y plus x. So those two y's cancel out. We got minus 4x plus x, which is a negative 3x. So that whole thing comes down to negative 3x. So it's minus y minus 2x times negative 3x, all divided by 2y minus x cubed. This is the part where a lot of people will just give up, but you can't. This gives us negative 6y squared plus 3xy. Now this minus and that minus are going to make everything positive, so this becomes plus 3xy. This becomes minus 6x squared, all divided by 2y minus x cubed. Alright, ooh, I don't have that answer on the paper. Let's see if I did something wrong. Plus, oh, there we go. That minus goes to there, minus. This goes to there, positive. This goes to here, this should be positive. And this goes to here, that should be plus 6. Oh, minus 6x squared. Oh, I remember now. Now you got to go, what can you factor out of everything out of here? We can factor out a 3. So this gives us, let's go negative 3. Gives us y squared. This is plus 6xy. This is so tricky, guys. So that becomes minus 2xy. And this becomes plus, this should be 2y squared minus 2xy. Nope. Oh, we can factor 6 out of everything. Sorry. Negative 6. We get y squared minus 2x minus xy plus y squared. Now, here's where this is super, super tricky. I'll rewrite that. This is negative 6. Sorry, guys. Negative 6 times y squared minus xy plus y squared, all divided by 2y minus x over 3. Now, what happened was I got this answer, which was 100% correct on a free response question. We could have ended all the way back here. We could have been done. But this is multiple choice, and I looked at my multiple choice answers, and this was nowhere on there. So I saw that those combined. Then I looked at this, and I said, anytime you feel like you did the work right and you get to the answer, you got to look at the original problem and go, well, the original problem, x squared minus xy plus y squared equals 1. So you go down to your problem, x squared, this is x squared, minus xy plus y squared, that equals 1. Only in this problem, that equals 1. So our answer is negative 6 over 2y minus x cubed, which is answer A. Huge problem. Those of you who are just writing down an answer on this one, you're totally faking it, and you're not learning. All right. Hope you guys enjoy implicit differentiation.